Hello, my name is Shafie and this is my EM3 assignment.
We will be referencing it to this graph where we have a point on the graph as xn and yn. Using these points, we want to find the next point on the graph. Hence, we will draw a tangent line across that point. As we already know, in order to find the gradient, we will take y2 minus y1 over x2 minus x1. And this gradient value is equals to the dy over dx values. So in order to find the next point, I have drawn a point on the tangent line with a y value of yn plus 1 and xn plus h, with the h value being the step size, or also the difference between the xn and the next value. These values form a right angle triangle underneath the tangent line. So beside the step size known as h, we also have the hypotenuse, which would be the dy over dx, or also the gradient. Then besides that, we have a missing value known as the opposite, which would be the step size times dy over dx, or the gradient value. Now as shown in the picture, we can see that the Euler's formula would be yn plus 1 equals to yn plus h times the dy over dx. What we're doing is basically using yn, the previous point, and the step size times the gradient in order to find the opposite value, which will then add up to form yn plus 1. Now for the next portion, I use both the Euler's formula as well as the general formula that was given. As seen above, there is the xn value, yn value, and fxy value. The xn value indicates the step sizes of the x-axis, and for me, I have chosen to use a step size of 0.2 between each value. The yn column will indicate the values of the y-axis, in which we are trying to find using the Euler's formula. For the next portion, the fxy column, I will be using the given general formula in order to find the values. The formula being dy over dx equals to x squared plus 1 over y. With this, I will input the values x squared plus 1 over y into the cell using that formula in order to find the value. As shown above, I will use the yn column and input a value of 1 into both of the columns. When xn equals to 0, as we increase the step size, we will use the formula to find the next yn value, which would be yn plus 1. From then on, I will be repeating this formula and increasing the step size by 0.2 each time until I finally reach a step size of 1. And from then on, I will get the final answer, which will be 1.909471 for the yn value. Lastly, I'll be showing the value of y1 using the general solution that was given. As shown in the picture above, I've used the general solution, which was dy over dx equals to x squared plus 1 over y, and from then on I got an answer rounded up to 1.9149. And compared to the answer I got using the Euler's formula, there is a small approximation error of around 0.00542. And I found this approximation error by comparing the answer that I got from the Euler's method and the answer that I got by using the general formula. This approximation error could have been caused by the fact that the points that we are finding is based off the points on the tangent and not on the curve. And because of this, there will be a small difference. That is all for my assignment video. Thank you for watching. Bye bye.